Review of final assessment notation continued. Number 4 has the instructions that read simplify. Number 4 is a 5 over 3r minus 1 minus 5, overall being divided by a 5 over 3r minus 1 plus 5. So when we're looking at this one, what we can do is start by simplifying the numerator and simplifying the denominator to begin with. So I have a 3r minus 1 in a fraction form up here in the numerator. So to clear that fraction, I'm going to multiply both terms by that 3r minus 1. It's going to clear on the left side, leaving me with just a 5. On the right side, I'm going to have a minus 5 times the 3r minus 1. I'm going to do the same thing to the bottom to simplify this problem and to clear the fraction, so that I end up with a 5 plus a 5, 3r minus 1. Now I can continue to simplify by distributing this 5 through. Before I do, however, I want to turn this to a plus sign and push that negative over onto the 5 so that I know that this is a negative 5 that's distributing through. So negative 5 times a positive 3r makes a minus 15r. A negative 5 times a negative 1 makes a positive 5. Then I'm going to do the same to the bottom, to the denominator's position. I have a 5 times a 3 to make a 15r, a 5 times a negative 1 to make a negative 5. So continuing on, simplifying, combine like terms, so I have a 5 plus a 5 to make a 10 minus 15r, a 5 minus a 5 to make a 15r. Now I'm going to look at this top. I can factor out a 5, so I'm going to pull a 5 to the outside. It leaves a 2 minus 3r in the parentheses. On the bottom, I'm going to break this 15r down so that I have a 3 times a 5 times an r. Now I can simplify by looking and eliminating values from the numerator and the denominator's position. So I have a 5 in the top and a 5 in the bottom, so I'm going to cross those out. And I'm now left with a 2 minus 3r in the top and a 3 times r to the bottom. Now it's as simplified as it's going to be. Moving on to question number 5, the instructions read, find the root. Assume that the variables represent non-negative values. So I have under the square root a 144. If I looked at these individually, I can look at this as the square root of 144, the square root of x to the 12th, and the square root of y to the 14th. I could also look at them all under the same radical sign and break this 144 down and see if I can square it, which I know makes a 12 times a 12 makes a 144. Under here with the x to the 12th, I could also see if I can square that one. It's just splitting it in half. So x to the 6th times x to the 6th. And the same with the y to the 14th, a y to the 7th times a y to the 7th. So once I have them paired, I can take them to the outside. So I get to move, with squared, I get to take the 12, an x to the 6th, and a y to the 7th to get the final answer of 12, x to the 6th, y to the 7th. Now it says find the indicated value of the function. So here I have the function of x equals the square root of a negative 3x plus a 7. And it says find the function of 0. So I'm going to plug a 0 in where I see the x and solve the problem. So I have a negative 3 times a 0. So this clears the negative out from underneath the radical sign, so I'm left with the square root of 7. I'm going to leave the square root of 7 as it is. It's a prime number. if I try to take the square root of 7, I'd end up with a number that is a decimal, that is continuous and non-repeating. So I'm going to leave it in the form of square root of 7. Number 7's instructions read, find the domain. So I have number 7. I'm going to work out the function of x equals the square root of x minus 18. Notice that the function of x values need to be real numbers. So the x minus 18 needs to be a positive number, or a 0, to have a real number when taking the square root. So that means that my x minus 18, when solved, needs to be greater than or equal to a 0. Well, if I solve this inequality by adding the 18 to both sides, I end up with x needs to be greater than or equal to an 18. I can write this into a set builder form where I have x such that x is greater than or equal to 18, or I can write it in the interval notation form where I have a bracket which indicates that it can be equal to 18, followed by the 18 comma, going towards all positive values since x is greater than 18. So I'm going towards the positive infinity with closed out with a parenthesis. That's my interval notation. Question number 8, the instructions read, rewrite the following using radicals, then simplify if possible. So looking at this 256 raised to the 1/4. So what this is indicating, this 4 is telling me that I'm taking a root to the 4th. So I'm going to write it out with my radical sign with the 4 up here, with the 256 underneath. Well, when I look at 256, if I had a 4 under here, 4 times 4 times 4 times 4 would create 256. So since I have the 4, I can pull that out, and I end up with an answer of 4. Rewrite the following using the radicals, then simplify if possible. Assume that all variables represent a non-negative value. On question number 9, I have 19 with my w raised to the 1/2. What that means is that I have a 19 with the square root of a w. The next one reads, write the following in exponential form. Assume that all variables represent positive values. So on number 10, I have an m under the square root, an m to the 9th under the square root. So I'm going to write this into an exponential form. So the m in the fraction, what would look like in the numerator's position, I need to put how many m's I have. I have to the 9th power over whatever my root is. In this case, it's a square root over 2. So m 9 raised to 9 over 2. Use the rule of exponents to simplify. Write the answer with a positive exponent. Assume that all represent positive values. So we have an x raised to 1 over the 7th power times an x with a 6 over the 7th power. So we're going to combine these together. Whenever we have a base that's the same, our exponents are going to sum to one another. So we have an x with a 1/7 plus a 6/7. They're already they're already set up so that they have like denominators. So I can sum them together. If they weren't, I'd have to rewrite them with their equivalent fractions. But I can add these together. So I end up with a 1 plus a 6, which is a 7 over a 7. Little error there. Can correct it. So we end up with an x with a 7 over a 7. Well, a 7 divided by a 7 is a 1, so I have x to the first power, which will be just x.